Good morning, mathematicians. I hope you're all feeling spooky, because it's a spooky time of year. Yes, you should all be very, very afraid.
Good morning, mathematicians.
Because we're doing the spookiest thing of all today.
Spooky.
Spectral sequences, of course.
Spooky time of year. Yes, you should all be very, very afraid.
I'm just sitting here watching myself. I didn't mean to do that. Okay, whatever.
Today. Spooky. Spectral sequences.
It is always interesting watching yourself several seconds in the past. I think so. You should try
I'm
it.
just sitting here watching myself. I didn't mean
Oh,
to
look.
do that.
Now there's a whole infinite window of
It
us.
is always interesting watching yourself.
Wait, there's 3 of us? There's 4 of us? Oh my god, I can't count. Okay, my head's hurting. I gotta close that. Oh, this is not where I want to be. I want to be here. Okay. Ooh, I'm a little bit tired this morning. I went to bed a little bit late. That doesn't help my brain work good for spectral sequences, I'll tell you that. So, I think we had left things off. I think I had convinced myself somewhat of this, that these spectral sequence things were correct. And, yeah. Have I tried cocaine? I don't know if I can say such things. There could be kids watching. Yeah. Is it good for long-term health and mathematical production? That's the other question. And my calendar is saying I have things to do today. Probably should check this before stream started. Oh, yeah. Nothing I gotta do till later. We are good. Okay. It would be, I'd love to do an experiment where you give groups of mathematicians different drugs and you ask them to just write about math. Sort of like Drunk History. Sort of a mix between Drunk History, if anyone remembers that show. And then there was also I remember seeing this one series of portraits of an artist who drew different self-portraits under the influence of different substances. So, I mean, sure, I could do this as one person alone, I suppose. But what would be more interesting, I think it would be more interesting to get a group of mathematicians, because you want a few different people with the same we got to be scientific about it. Okay. Oh, right. And we said something about divided power stuff. So, let us now, we're going to look at, let's look at the case of SU as well. Let's just keep going. Let's do another example. N equals 3 and 4 collapse for degree reasons? That I don't understand. Here's an example in which we are actually computing the cohomology of the total space. Okay. Let's see what I can do on my own, even though I've already seen a little bit of what they are writing. So, what do we have? SU, we've got SU n minus 1 into SUN. Good morning, Arad. To SUN into, what was it now? That's how bad my memory is. S2n minus 1. Let's make life easy on ourselves. Let's do s equals 3. This is what, 5? Yeah, let's make life nice and easy. Okay. And so our spectral sequence will have pages E, S, base, fiber, HT, SU2. Right? Is that what it was? Yeah, base, fiber. Yeah. Okay. And let's see, what is the dimension of SUN? Let's look that up. He is cooking. Hell yeah. Hell yeah. We cooking today. Is it n squared minus 1? Is that what I was seeing in the preview? N squared minus 1. Okay. So this is n is 3, so that has dimension 8. Maybe dimension 8 here, and dimension 3. Okay. So let's set up our E2 page. Let's see if I learned my lessons from yesterday. So when we put this equal, when we make this 0, when we make this 0, yeah, so we should just have a 0, sorry, a z here, 1, so 0, 1, 2, 3, 4, 5. Maybe I'll give myself a little more room. Lesson learning is for losers, yeah. We making the same mistakes forever. We're staying in samsara, baby. This is what I want, right? Oh, and then this one should be, let's see, 0, 1, 2, 3, 4, 5. This should be z. Right? We know the others are 0? Yes, we know the others are 0. We know the others are 0. Yes. Yes, 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 yes. Of course. Wait, S is the... No, wait, what have I done? S is the x-coordinate. S is 0 here. So making T... Gosh, I'm not learning anything. H... which one's X and which one's Y? This is H0. This is H0 of the base. No, we don't know these ones. We know the bottom row. We know the bottom row. What I drew here is when Y is equal to 0. I got this backwards. 1, 2, 3, 4, 5. And then the rest are zeros. EST, S is the horizontal coordinate. Wait. No, this whole time I've been drawing S as the x coordinate. S is the x coordinate. Like, that's what we did last time, right? Yeah, S is the, horizontal. Horizontal means X. Yeah, okay. Great, okay. Okay, but maybe we can say some things here, because we do know that SU2 is three-dimensional, so we do know that it will die above this. So we know that we have a whole block of zeros here. So great. And maybe everything else is question marks for now. No, probably there's some vertical things I can fill in if I think for half a second. Wait, what will die? What did I say? What did I say was gonna die? I don't remember. Hello, Abdullah. How's it going? Let's see. Right, if S is 0. Yeah, I can't say anything in the other cases. To be sneaky, you also know SU2 is an oriented manifold, so you have Poincare duality. I don't want to use that yet. But you're right, actually. So that gives me the top Z, right? That should give me the top Z. Hello, Mom. Hope you're doing well this morning, and that your online math sessions went well. Poincare duality, okay, I will use it. You know what, Arad? I will use it, because probably it'll be useful here. Poincare duality should tell us this. Okay. And we do know stuff about the E infinity page, right? Because that should be the cohomology of SU3. And we know, mind you, 8's a big number. But I guess that tells us we know that our, cohomology groups will die after a certain point. I mean, we know in degree 0, of course. We know in degree 0 we'll have a copy of Z. So we can always exploit that fact, right? So Z should be E infinity 0, 0, which will be H0, or, yeah. Well, okay. Maybe that's not that useful at this point in time. Okay, let me think. Now, what do we need to do? I guess we sort of argue about when. Wait, are we even starting with SU2? Oh, yeah. Okay, wait, what is the cohomology of SU2? Wait, are we saying that we know it in this example? That is what they said, right? In which we are actually computing the cohomology of the total space. Oh, they're doing an argument here for n equals 2. We could have done n equals 2. That recovers this vibration. Has non-trivial cohomology. Wait a second. They're doing a simpler example here. What? SU2 is simply connected. Why are they doing a simpler example than what they said they were going to do? And then they do... Huh. Okay, maybe we should start where they're starting. Maybe we should start where they're starting. In fact, they don't even have SU3 or SU4 showing up in their stuff. Then why did they write collapse for degree reasons n equals 3 and 4? It is also S3 among things. Oh, SU2 is S3. Oh, right, it's right here. It's right here. Okay, I'm gonna go back and I'm gonna make life easier on myself. And do SU1, SU2, and what goes there? S5? No. Yeah, S5. Wait, S3? Now I'm going in circles, getting confused. S3's in the middle? No. Okay. SU1 is trivial. And we see that SU2 is S3. Oh, okay. So then they just don't do that step. Setting n equals 3 gives this vibration. Okay. And then they actually do some work here. So that's what we'll do. We'll do the n equals 3 case. We'll do the n equals 3 case. So this is SU2, which is S3. And this will be SU3, which is... Wait, isn't that the one we were just saying? So we are doing this one after all. Okay, never mind. Okay, everything's fine. Oh my gosh. I can't count. I can't think. Yeah. And this is S5 here. Okay, great. So we're back to here. So let's see. So that actually tells us that this is going to be it'll be 0 unless it'll only be non-zero when t is 0 or 3. So actually we can wipe out everything in the middle here. Boom. Look at that. And otherwise it will be the so when t is 0, this is z. Oh wait, this is 0 still. And now it will just be the z. No wait. This we don't know is 0. Do we? No, there should be a z here, shouldn't there? Because that would be the z-valued cohomology of S5. Yeah. So, and then in 5 we should have it. So it should look like this, right? Am I crazy? No, wait, no. This is the rows of zeros. No, what am I doing? Okay, I'm getting myself so confused. Okay. I should be writing things out more. That's always the problem. Okay. Let me think. So when t is equal to 0, which is the y value, right, that's what we have here. Right. Right, okay. All the other y values are zeros. All the other y values are zeros. The only places where the y values can't be 0 is 0 and 3. And then in row 3, right, we just get z's here. Nice. Boom. Okay. Awesome. Awesome. This is the simplest E2 page we've ever seen. Maybe I'll just clean all of this up to make staring at it easier. Nice. Okay. At some point, I'll have to stop writing all the zeros. Well, look, I've stopped. I can stop at any time. I can stop anytime I want. I just like to. I can stop anytime I want, though. Okay. This is fantastic. So. Now we need to think about our differentials. Well, let's think about I guess if we think about this z over here, it will survive. And of course it does, because maybe you'll record a video today about drawing zeros, about never stopping drawing zeros. And of course this survives because we already know that we should get a homology. We already know that we should get some homology in degree 0. So this is, wait, SU3, is that what we're computing now? Yeah. That Z has grit and gumption. Interesting. Well, maybe I'll give it a little look-see when it shows up. And this Z should survive. Also, again, just because differentials. So that is in degree 8. And that is also not surprising because SU5 is 8-dimensional. So I guess we don't need to have something in top cohomology, but you know, it's kind of a sphere vibed thing in 8 dimensions. So on a vibes-based level, this checks out. Now, the question is, will the only way that these z's could possibly die is when and if we get a morphism between them. Can this happen? And what will happen there? Will it be an isomorphism? What will happen? Well, what could go on here? You do need to have something in top cohomology. Do we? Always? Oh, yeah. Maybe I'm thinking homology. Do we always need something in top cohomology? Oh. Okay. Yeah, let's start with can it happen? Exactly, Leo. So we're going to ask about a certain page with x coordinate 0, y coordinate 3, and let's see if we can go to, yeah, if it's not compact. Yeah, am I crazy? I think you're right. Yeah, I think you're right. Then it doesn't need a top thing. And the question is, Well, the x coordinate is jumping by 5, so r would have to be 5. Non-compact, never heard of it. Yeah. And then what would happen to this? Well, this would be 3 minus 5 plus 1. So no, we won't ever hit it because these things only hit each other. These things only hit each other. Yeah, so it just misses. And that means they all survive. And so, what? We have a copy of Z in degree 3 and degree 5? Is that it? Is it really that easy? No. Come on. Given that we know the cohomology of the fiber and base, we can fill in all the groups of V2. Okay, so we at least got that right. Yeah. Oh, I guess we need to give degreed generators. Do you think it's possible to create a political system out of pure maths? Well, I don't know what that would mean. I don't know. What does it mean to create a political system? I don't even know what that means. Like, what are other political systems created out of? I don't know. Certainly, of course, I mean, spend any time on the internet, there's all sorts of crazy, wacky political ideologies people love putting themselves into. Could one make a math-based political ideology? Sure. I'm sure. The human mind, we've got powerful imaginations. I don't know what you mean by out of math only. I don't know what your question means, unfortunately. Maybe he means Terrence Dow should be president. Well, let him run, I guess, and see how it goes. Whoever is the best at computing spectral sequences is in charge. Hey, let's try it. We need to do more science with political systems, right? We haven't even, if you think about all of history, there hasn't been that many different political systems. We should be getting freaky with it, you know? Let's try some weird stuff. Let's try whoever computes spectral sequences best is in charge. Let's see. Limits us to differentials. There are no two non-zero groups that are 4 apart vertically. In short, we observe there is no space at all for non-zero differentials. In such situations, we say the spectral sequence collapses for degree reasons. Yay! So we were right in this extremely simple example. Yay! We did one on our own. It was for babies, but we did it. Okay. The ring structure is also easy to extract. Okay, we didn't do this part, but I'm going to need it to explain to me. Lord of the Flies Math Department Edition, yeah. Basically your math department already. There's one philosopher who tried to do metaphysics with set theory. Well. Thank you, Leo. Thank you. I'm the best. Just, here's the evidence. After all my stupid mistakes, I finally did this very simple example on my own. So, never forget who the king really is. Alongside help from chat as well. So never forget who the king's top minions are. Can I show that is the ring structure? I don't know. That part I don't totally get. right? We call A3 and A5 some generators, and that has to be, there's a degree 8 thing, so that must generate it. I mean, okay. And somehow they get out the exterior algebra and 2 generators. I don't see why that's the case. So A3, A5 has to generate the top cohomology. Oh. Okay, I think I see what it is, because we can also say that since there's nothing in degree like 5 or 10, we know that A3 and A5 have to square to 0. Right, A3 and A5 have to square to 0. But I don't get, I mean, if this was the exterior algebra, we would want this to be anti-symmetric, and I have no why. Humility, yeah. Yeah. Yeah, my mom knows how humble I am. Here to remind me. Greatest mother on the planet. Mother to a king. Mother to a king, so greatest mother on the planet. There you go. How's that for humility? I look too handsome to be in math. Actually, I did used to have a shirt that said I'm too handsome to do math. I don't know what happened to it. I think it got worn out, but maybe I should buy another one. Yeah. What mathematical structures we cannot still compute, according to me, completely? Non-computable real numbers. Those are things that by definition we can't compute. So there's that. Squares are definitely 0. Yeah. But I don't get A3. I'm too ugly to not do math. I should get both. I should get both, and swap them out based on like how I'm feeling that day. What about infinite groups? We can definitely do computations with infinite groups, but I mean the word problem on groups is undecidable, for example. So for certain infinite groups, there's stuff we can't compute there. Yeah, maybe you can't compute. Maybe I can't compute them. Yeah. There was one proof which is thousands of pages long. Oh yeah, there's more than one. Classification of finite simple groups is like 10,000 pages, or the original go at it was. I think they're trying to shorten it, but SE3 is the structure of an exterior algebra on 2 generators. Yeah, I don't know. The only part I'm missing here is the anti-symmetry. I have no idea why that should be the case. Name every finite group or you're a fake fan. Have I read it? No, gosh, I haven't read it. Nor will I ever. Yeah. What about live stream reading through all 10,000 pages of the classification of finite simple groups? Okay. So let's see. Same reasoning allows us to quickly obtain this. We use this vibration. Similar tricks. No space for zero differentials. But there are 2 non-zero element groups in this that differ by degree 6. Collapses for degree reasons. We got a similar kind of thing. Okay. Keep in mind, multiplication is not quite commutative. It's graded commutative. What does that mean? What does that mean? Oh, Oh, is there a Leibniz rule? Oh, can we use the Leibniz rule somehow? Can we use the Leibniz rule somehow? What? Okay. A d3, so the differential of this has to be 0. And this says that it's A3, A5 plus some sign. I don't remember what. A3 differential of A5. Aren't those both 0? No, I don't know what's going on. Yeah, because the thing would have to work out to be... No, I thought maybe the Leibniz rule could help us. Is there no way for that proof to be smaller or human readable? Well, people are working on it. People have been working on it so long that, as I understand, several mathematicians have passed away, and they're on like their 4th attempt at writing a shorter, more concise thing before the people who know most of it leave this planet. So they should have said this in the article. The product on the E2 page, which here coincides with the E infinity page, is equal to the cup product, but only up to a specific change in sign. Yeah, but then how do you determine purely here? How do you determine what that sign is? How are we even sure that proof is legit if no one has read it properly? Well, it's not that no one has read it properly. I mean, the thing is, like, I don't know. How do we know that the proof of... I mean, any theorem in modern math, like take a random paper, right? Take a random paper on archive, right? Let's look at the first paper here. Okay, mind you, this one isn't published yet, right? But let's look at this paper. Well, read it. What would reading the whole thing mean? I mean, you know, when you go and read this paper, do you go and start all the way at the beginning of set theory and trace all these proofs from the axioms? No, right? It depends on other results that have been proved. So in the same way, when I say the classification of finite simple groups is 10,000 pages, I don't mean that someone published a single 10,000 page paper that has just never been read. What I mean is that is constituted by many, like hundreds of papers. And those individual papers have been published. Okay, probably there's some mistakes somewhere. But that's just true of all mathematics. But it has been read by different pieces, by different people, published. The sign only depends on degrees, so it's computable. You just can't remember what it is exactly. Okay. Yeah. Yeah, I mean, everything should be formally verified eventually. No way you will have to start from scratch. You will abstract at many levels. Yeah, exactly. Okay. Next in line is H5. Or sorry, SU5. From the last calculation, together with the generators, are shown in the next picture. Most of the differentials are necessarily 0 for degree reasons. Right, now we got freakier stuff going. We got more things. Yeah, this is a big picture. but there are two D9s that need to be determined by further argument. This is a situation where we need to use the ring structure to even work out all of the cohomology groups. Interesting. The domains generated by that. We use the Leibniz rule. Sorry, embracing logic. I don't know what that says. Is there a translate thing? No, how do I? How do I copy? Copy? Yeah, why isn't there an option to copy paste messages? Oh well. Okay. By Leibniz rule, Chinese is simpler than math? Yeah, probably. Depends on the math. As this is 0, big button saying translate to English. Wait, what? Am I dumb? Did I miss the big button that says translate to English? Or are you messing with me, Rod? Your Chinese is not great? Well, Mandarin or Cantonese. Chinese technically doesn't make sense. Because it's Mandarin or Cantonese. Leibniz rule, we get this is 0. Similar calculation shows that this is 0. That rules out all potential differentials. So still collapses at E2, but not for degree reasons. Very interesting. Okay, and then at this point, we go by induction. Well, reading Mandarin or Cantonese is basically the exact same. That's true. Right. They use the same characters, but speaking is different, right? There are many more dialects than those two. What is the hardest area of math according to me? Well, I don't think that math is totally ordered. So I don't think that there is a hardest area of math. Yeah, I don't know. And hard for who? I mean, to an expert in infinity categories, a differential equations 1 class might be difficult. But your Mandarin's good enough that you can like follow what people are saying generally? Nice. Okay, so then from here we can prove by induction that the symmetric algebras are all this. The induction step is essentially a repeat of the previous argument, but starting instead with this vibration. Is essentially, but starting instead with this vibration, that's known by hypothesis, allows us to fill in all the groups on the E2 page, and then the only possible non-zero differentials. Wow. Very cool. Advanced math is very hard. True. You studied advanced math and Chinese is easier. Okay, good to know we have official opinion. Two official opinions, one from Leo as well. Your Mandarin is pretty simple, but years ago, with some work, you can maybe pick it back up. Nice. Is it true a lot of partial differential equations have no solutions? Yes, it is true. Yep. Okay, I wonder, can we do this one without cheating too much? Actually, I think we'll leave it today. Okay, I cheated a little bit, but I'm gonna try and do this one on my own as much as I can tomorrow. So yeah, Chinese grammar is much easier than English grammar. You'll say that. Fair enough. Okay. That's going to do it for today. I will see you all tomorrow. And yeah, QED.